Hey mathematicians, this is Mrs. Shopper coming to you with the Chapter 2, Section 1 video to help you understand this material. Kiddos, as we're getting into more of the geometry, we've got to really focus on making sure that we're studying differently than we've done in the past. As we're trying to be really successful in geometry, we have to look at things differently. You no longer can simply do the assignment and move on and be prepared for the assessment. You really do need to take time, study the vocabulary, work to understand the intricacies of the geometry. How does it work together? Get online with a friend or FaceTime and discuss. Talk through it, have study groups, do what you need to do. But in order to do well, you have to put in some extra effort. A lot of what you're going to be learning this year is 100% brand new. And you are going to nail it. You're going to do well. We just want to make sure we're doing the things we need to make sure that we're doing well. And so as you're going through and taking notes, I need you to write this down. I need you to pause the video. I need you to go back and listen to parts you didn't understand. I need you to reach out and ask questions when you're in class or message me if you're DLA. Please, 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 let's really try hard to kind of shift our thinking a little bit, and we're going to study differently, okay? So Chapter 2, Section 1 is on inductive reasoning and conjectures. New words. So what is inductive reasoning? Inductive reasoning uses specific examples to arrive at a conclusion. You're using specific examples, specific observations. A conjecture is a concluding statement reached by using inductive reasoning, which is using specific examples. Oh, you know what? Also, if you need to pause the video to write this down, that's what you should do. This should be in your notes, okay? In an effort to keep the videos not quite so long, I'm going to have you pause where you need to. So we're going to write a conjecture that describes the pattern 2, 4, 12, 48, and 240. So when I look at this, let's see here, I add 2, add 8, add 36. Okay, so I'm not really seeing much of a pattern there. Let's try, what do we multiply by? Times 2, times 3, times 4. Okay, so I'm seeing a little bit of a pattern here where I'm multiplying. The number that I multiply by each time increases by 1. So this would probably be multiplied by 6 to get the next number. So we're going to write a conjecture to describe this pattern. So the quotient of any two consecutive numbers is 1 more than the previous two numbers. Okay? So the quotient, which is division, so 12 divided by 4 is 3. That's 1 more than 4 divided by 2. 240 divided by 48 is 1 more than 48 divided by 12. All right, so that's my conjecture. Is that the only way to word it? No. That is a way to word it. So then we're going to use our conjecture to find the next item in the sequence. So 240 times 6, carry the, no 2 there yet. 4, now carry the 2, so it's 1,440 is the next term in the sequence. Going with specific examples, here I'm multiplying by 2, by 3, by 4. Figuring out these patterns will take some think time. They're going to take think time. It's not always going to come like this, and I need you to be persistent. I need you to continue to try. Think outside the box. Before you text your friends in your group chat, I need you to make sure that you're thinking on your own. As soon as you ask a question, someone else is doing all of the thinking for you if you're looking for the answer. We need you to do the thinking. It's okay to say, hey, can you give me a hint? It's not okay to say, what did you get for? All right? Talk through that process. Help each other learn. But as soon as you tell someone an answer, you're doing the thinking and taking that opportunity away from them. And we don't want to do that. We want to help. We want to guide. We do not want to take the thinking away. All right, next one. Write a conjecture that describes the pattern shown. So 3, 9, 18, add 6, add 9, or times 3 times 2. So if that stays the same, and then this is this part, and then we're adding on each time. So if we're starting with 3, 1, 2, 3, and then we add on 1, 2, 3, 4, 5, 6, that's how we get to 9. Here's 9, and we add on 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're at 18. So it appears that each time here we're adding 6, here we're adding 9. So I'm guessing we'd add on 12. Let's see what that looks like. If I add on 12, One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each time we're adding another row, and this row has 3 more than this row. So the conjecture is each figure adds 3 more than the difference of the previous 2. And so the next item in the sequence, 18 plus 12, is going to have 30. Are these the only conjectures? Could you have thought of something else? Possibly. Very possibly. All right? We all think different. We're all wired differently, so we're going to think differently. This is where my mind went. Yours might go a little different, and that's okay. All right, we're going to make a conjecture. This is tying it to algebra and some geometric conjectures. We're going to make a conjecture, so we're going to make a statement using specific examples about the sum, that's when you add 2 numbers, of an odd number and an even number. So step 1 is just to come up with some examples. Step 1. Odd number plus even number. Odd number plus even number. Odd number plus even number. What do I notice about their sums? When I look at this, I notice that all of these numbers are odd. So step 1 is to come up with examples. Step 2 is to analyze your results and see what you have. Step 3 is to write your conjecture, which would be the sum of an odd and even number is odd. That's my conjecture based on what we're saying. The sum of an odd and even number is odd. All right, a couple more, and then we'll be wrapping up. All right, so for points, L, M, and N, this is the information I'm given. The distance of LM is 20. The distance of MN is 6. And the distance of LN is 14. I'm going to draw a picture for this. So I'm just going to draw my line. And I notice that LM has the longest distance. So I'm going to put L on one end, M on the other. And this distance is 20. Okay? Now, I got to get an N on there. So N looks like it'll be closer to M than L. So I'm going to put that right here. This is 6. This is 14. So my conjecture is that points L, M, and N are collinear. That means on the same line, and N lies between L and M. So points L, M, and N are collinear. They're on the same line. And then N lies between them. All right? Conjecture, a picture. Draw pictures, draw pictures, draw pictures, draw pictures. All right, consider this conjecture. If 2 points are equidistant from a third point, then the 3 points are collinear. Well, if we're looking at what they have, so this is point A, we could say point B and point C. That would be an example to support it. I'm going to argue that it's false. Because it is possible to have A here, C here, and B here. And if we have an equilateral triangle, this third point is equidistant from both of these points. So this would be my counterexample. And we're going to get it more into counterexamples as we go. But a counterexample would be this. This proves that statement false. And I have to put these hashes in here so that I know that that means that they're equidistant. All right, and here's the idea of a counterexample. It's a statement that disproves a conjecture. Now, read this again. It is a statement that disproves a conjecture. We don't have an explanation. All right, so my example is all home students are hybrid. The counterexample is Brendan is a home student who is DLA. That's it. No explanation needed. We don't need to say that he stays home every day. We just need to prove it, right? So like another example I could say is that every single day it rains. Today it's sunny and not raining. That would be my counterexample. I don't need anything else to prove it with. It's just a simple statement that we do that, all right? Thank you for listening. Rewind what you need to rewind. You are fantastic. Good luck on your assignment. Message me any questions you have. Take care.